And welcome everybody to the Daily Space Weather. It's a Saturday night special. We've got spectacular imagery. Most of the activity on the closest star going on in the southwestern limb, but the biggest story will be geomagnetic storm impending. It could arrive at any moment. We'll tell you how to see it, when to expect it very soon, and lots more tonight at the Smash News Network. Least busted name in news. That's a 24-hour video. And let's take a brief tour of the closest star's features. You might see a huge plasma filament down there to the southwest of our Earth scale. Active regions north of the Earth scale. Here's a quick look at the equatorial zoom. And here's the most active region, this couple of sunspots in the southwest. They have indeed produced at least one M-class solar flare event. There's an extreme close-up of that most active region, the highest X-ray producer on El Sol for the past 24 hours. That's what happens when you call a solar flare watch. If you know how to forecast solar flares, you'll tend to agree. Here's what's going on in the northwest. There's a huge filament there becoming a prominence right before your very eyes. Let's go even closer look at that. Great absorption feature there. And let's briefly look at the northeast. Filament rising over there becoming a prominence as well. So lots of large filaments on the solar disk. Likelihood of coronal mass ejections in the earthly vicinity, nearly 100% moving into the next 24 hours. There's an extreme close-up of that recently risen prominence. And before we look at any other views, let's take a moment to endorse the channel. Yeah, so the main way to support the channel, folks, is by becoming a member of the Smash Team at smashomash.com/Smash Team. We created our own website, launched back in October of 2021. If you want additional content, we put up a post about something to do with economics today. Yeah, that's only for Gold Smash Team members, so a little bit of economic forecasting. Yes, it does go hand in hand with space weather sometimes. Peter Schiff ought to be watching the videos if he's not. So yeah, shout out to Peter Schiff from the Smash News Network, Least Busted Name in News. The following is another series of paid endorsements brought to you by the Smash News Network, Least Busted Name in News, and these videos are brought to you in part by our Smash Team members, especially Silver and Gold Smash Team members. Today's featured product is Pick 2. It's not going to be fast, cheap, and good. It could be fast and cheap and bad. Don't do that. It could be good and cheap, but slow. That's okay if you have a long time frame. It could also be good and fast, but not cheap. That's the portion of the Venn diagram I tend to live in. Fast and good, just not cheap. So, I mean, look, you just pick 2. Any project manager that wants the project to be fast, cheap, and good is going to be sacrificing one of the 3 things. So be prepared for that. It'll look like a big debacle, but they'll give up one of those 3 things if they'd like it to be fast, cheap, and good. By the way, massive savings going on at the Redbubble shop. Save up to 40% site-wide. So we make our memes sometimes into products. It's the Pick 2. Because it ain't going to be fast, cheap, and good. Links below the video to the Redbubble shop. Perhaps a great throw pillow for your mom or aunt. Maybe your aunt is a bad project manager, or maybe she's a brilliant project manager. Maybe she trains project managers. Who knows? Today's featured product from the Amazon shop at amazon.com/shop/smashomash is magnesium. I take mine before bed, along with zinc. Not every night, folks. Only every other night. Yes. Magnesium plus zinc. Don't take your magnesium with calcium. They are co-antagonists, but you might find that magnesium helps you sleep better. It's also good for bone and muscle health. Amazon.com/shop/smashomash. another series of paid endorsements at our Amazon storefront. So check those out if you want to support the channel that way. You can also find on our homepage lots of links to the Redbubble shop, to the Amazon shop, to this YouTube channel, Facebook, Instagram, the Discord channel, and more. We're even still on Patreon, believe it or not. And one of the links you can find there is to Hemp Lucid. Yes, Hemp Lucid. So if you haven't seen that, check it out. Enter the promo code SMASHOMASH10 to save 10%. Also massive savings on various different products site-wide. So check it out again. Enter the promo code SMASHOMASH10 to save 10% on everything. Promo code SMASHOMASH10 on checkout. It'll save you $4.29 on the full spectrum CBD, for example. So hemplucid.com. Also a link to our storefront below the video to that, and also on the homepage. We just showed it to you. And let's get back to important space news, and that is an incoming geomagnetic storm, folks. So a couple different ways that you might be able to figure out how to view the storm. Check it out. One of the ways you could do it would be by checking out the Geospace Delta B map. So that's always a good one. That is going to show you ground magnetic perturbations. So it's changes to Earth's B field here. It's going to show you the most likely places to have telluric currents below your feet and aurora above your head. So that's one way to figure out how to find the aurora tonight, folks. So tonight into tomorrow morning, expecting some could be major geomagnetic storms based on recent activity and so on. We'll even be talking about red auroras later in the video, so make sure you stay tuned for that. Another way to look for the aurora is check out the geoelectric field map. So that's empirical data on induction into the power grid in North America. So when that's lighting up, the sky might be lighting up at the same time. So the geoelectric field map for US and Canada could be very helpful for our North American viewers. So there's that. So it's not only your latitude, it also has to do with your substrate, of course, which affects how much current gets induced into your local power grid. But there's the empirical data for that. Another way to look at it is if that's all Greek to you, one thing you could do is you could view the 30-minute auroral forecast on the Space Weather Prediction Center, swpc.nasa.gov. I'm sorry, .noaa.gov. swpc.noaa.gov. It's NOAA's website, not to be confused with NASA. So yeah, the auroral forecast might also help you out. I've heard it's often not super accurate, so hey, I prefer to use this one. And at the moment, things remain calm. So expect it to light up sometime tonight. I mean, we thought that one was moving a little bit more slowly than NOAA and NASA did, but I would tend to listen to them because trajectory and speed are not our forte on the channel. Just early forecasts of an Earth-directed CME. Trajectory we cover. Velocity, not so easy to cover. So, again, you can also use the ground magnetic perturbations map. Can also show you where the aurora would be likely in your neighborhood. We'll show another view of that from the world view a little bit later in the video. First, let's take a look at what's going on in terms of sunspots briefly. They're all in the western limb at the moment. And we've got something like 91 sunspots, I believe. There is colorized magnetogram like the continuum we just showed. That is November 10th and November 11th to date. Also, Iceland. Parts of it are being evacuated, and there's a great ad that just popped up out of nowhere. So yeah, Iceland, folks, it's being evacuated. So the southwestern peninsula, known as the Reykjanes Peninsula, being evacuated because it's only a matter of time before a major volcanic eruption happens. So that should be interesting. At the moment, volcanodiscovery.com is only showing one erupting volcano, Ravenador. So I don't know if somebody's on vacation there. Maybe somebody's out pole vaulting the caldera. Anyway, let's get to earthquakes. So they're the past 90 days, and it hasn't been a major day for earthquakes over the past 24 hours. We'll cite those over of a 5 magnitude or higher. And yeah, a couple quakes in California there. Iceland did have a 4.7. I believe the largest quake of the past 24 hours was a 5.7 at Indonesia. That was at 6:41 this morning on 11/11. A 5.7 on 11/11. Then Vanuatu had a 5.5. That was at 12:35, and that's it. Only 2 quakes of a 5 or greater magnitude. And here's some more space. There's ionized helium on the closest star. And you might see a little CME happening up in this area. That is not likely to have any earthly directed components. And here's the equatorial zoom. You get a little bit closer view of the most recent flaring activity as well as that minor CME. A bunch of filaments visible. Just good stuff from the Solar Dynamics Observatory. That's a fine series of images. And again, here's the most active region. This series of sunspots in the southwest have indeed produced an M-class flare right toward the end of this video. Right in... No, just right at the end. I don't know. It's on there, and don't worry, we've got lots of spectacular images tonight. And, oh, I've got an even closer view than that. Okay. Well, don't miss that. There you go. There's an extreme close-up. How you like them apples? Again, that M-class flare was right toward the end of that clip. These are all 24-hour videos in ionized helium, 304 angstroms. Next, looking at things like the 10.7 centimeter radio flux, now down to 142 solar flux units. There it is in a 1-year graph, conveniently compiled by Solon.info. The black line is the radio flux, the red line, the sunspot number. Again, sunspot number is actually around 90. It looks like 93 actually on that graph. And the Space Weather Enthusiast dashboard here is forecasting geomagnetic storms tonight, well into tomorrow. So up until about 12 noon Universal Time tomorrow, expecting geomagnetic unrest at the very least. Now, we forecasted this to arrive a little bit later, so far it's, well, I don't know, whatever. It is a thing. And here is the NOAA forecast in graphical form, NOAA's Enlil spiral. Just remember, folks, NOAA is more adverse to false positives. NASA is more adverse to missing any individual events. So NASA is much more sensitive. NOAA is a lot more concerned about over-forecasting geomagnetic storms. So that's NOAA. Here's NASA's forecast. I don't believe either of these have changed since yesterday. They're both fairly consistently in agreement with each other. You can see in the center pane there that NASA is forecasting a little bit more of the ejecta to miss Earth to the north. That is consistent with the CME that we showed on the channel. Anyway, moving right along to Earth's magnetic moment from space. And let's full screen that while we're at it. So here are the last 4 hours, and I think we might have switched active spacecraft there. It's neither here nor there. We're going to show you both spacecraft, the ACE and the Discover. There have not been any major variations in the solar wind over the past 24 hours, really. But that's the past 4 hours modeled by the Space Weather Modeling Framework. Keep in mind it does use the active spacecraft. So maybe some stuff coming in there in the past half hour, but I don't really think so. Anyway, here's the world view, the global geomagnetic ground magnetic perturbations map. Again, 4 hours of changes to Earth's B field. And you can use that on the global scale to forecast where to see the aurora. So KP index still here quite calm at KP1. And expecting it to come possibly as high as 7.3. NOAA's forecast is for about a 6.3. So that's a fairly tight forecast there. And it looks like everybody's largely in agreement. NOAA, NASA, SCOVE, and SMASHO. So that's always a good sign. And here's the data from ACE. You can see we're viewing the ACE right now. One of the 2 solar wind spacecraft at Lagrangian point 1. ACE is showing 3 protons per cubic centimeter for the solar wind density, solar wind velocity here, dipping down to about 450 kilometers per second. Here's the Discover, showing a little bit higher density solar wind, but a similar speed. So that looks like no CME impact yet. We're almost on the 12th. So the Discover is coming back with about 9 protons per cubic centimeter for the density and a very similar velocity there, 476 kilometers per second. And next, showing the GOES magnetometers. There you have those. Expect to see some major gyrations in those as a major CME impact arrives tonight into tomorrow morning. And next is our top view ecliptic plane field plot. So this is just, I mean, this is one of those things where I got answers to questions not asked by viewing this data. And it's just showing you the magnetism of these portions of the solar system, basically. And yeah, we've got this sector boundary crossing that's really taken its time to show up. So there's the last image. I'm gonna bring this back. So I'm gonna bring the previous frames. You can see there is indecision happening over there in the east. So that's once again a magnetic tug of war happening over there on the east side of the sun. And once that ends, you can expect to see a bunch of sunspots pop up in that portion of the solar disk. So it is rotating into the earthly zone here. Yesterday, I believe I forecasted that there might be some sunspots showing up in the southeast. And now, still could be the case. Keep in mind, magnetic tug-of-wars on the sun always end up with one polarity winning. Which polarity do you think is going to win? Let us know in the comments. I think South Pole. Anyway, here's our line of sight field plot. Here the sun's B field is depicted in blue, photosphere magnetism in grayscale, polar fields in red and green for south and north respectively. Next, our line of sight ecliptic plane field plot, and once again you'll see over on the east side, you'll see a lot of gyrations happening over there, as the polarity is yet to be determined as that portion of the sun rotates into the earthly facing zone. So again, that magnetic tug-of-war always ends up with one side winning. When it does, expect to see sunspots forming in that portion of the solar disk. It's like a miniature Terminator event. And don't forget to press the like button, folks. If you have failed to press like, then there will be repercussions, possibly even for your soul. Accountability always comes, folks, so don't forget to press the like button. If you're new to the channel, press subscribe, tell your friends and foes about us. Press the share button, leave a comment. You know, we do stuff besides space weather. And we've just got the world's most comprehensive daily space weather content and most detailed imagery of the closest star you'll find. Our shorts have been, shall we say, popular. So check those out. Perhaps you'll see some clips you never saw before. I don't know. But don't forget to press the like button, or else. Next, move to coronal holes. And let's pause for station identification. You've reached the Smash News Network least busted name in news. Here's our line of sight coronal hole plot, which brings us to, guess what? Coronal holes. That's a segue. North Pole coronal holes in the south, South Pole coronal holes in most of the solar disk. So here's what's going on. These are north. Earth remains in a North Pole current sheet, by the way. And over here we've got south, south, and more south. So that's the current configuration of coronal hole polarities. And before we get to sunspots, let's talk about sunspot stats. So the sunspot number, I think I said this before, it's now down to about 93, 91, 93, something like that. And like we said yesterday, we're having an increasingly likely chance of large solar flares. I think the most complex sunspot is now going to be this group, 3483, but it's one of these two. So this group here and this group down here certainly have a potential to produce large flares. We've already seen one M-class event. Let's take a look at those from SDO Continuum. Here's another 24-hour video from the Solar Dynamics Observatory. As we wait for that magnetic indecision to play out in the east, we've got an increasing likelihood of major solar flares in the west. So that's what's going on with sunspots. And as far as things like energetic particles and solar flares, no spikes in the proton flux, but we could certainly see a spike in the proton flux. So that's definitely a thing that could be in the cards, is solar energetic particle events. So the higher the likelihood of flares, the higher likelihood of additional CME impacts, the higher the likelihood of SEPs. I won't get into the physics of it, as this is the daily space weather. It's just a fact that those things are correlated. And there's the most recent flare. It was a small M-class event of about M 1.25, about an M1.25 class flare. There we go. Peak flux was at 1730 Universal Time, and it was a double peak, but the second peak was kind of lower. It was a C-class event. And here come solar flares from SDO. So, oh, wait a minute. That's not right. Here comes solar flares from SDO. There's another 24-hour video for you. 131 plus 94 angstroms, and we're going to zoom way, way in. So there's the equatorial zoom. Here's a close-up of the southwest. And there's a money shot for you, the most active region there, an extreme close-up. So that's not too bad. And before we get to things like coronal mass ejections, let's take a look at what's going on overhead. So here is a lovely star chart from skyandtelescope.org. Just put in your location if you want to create your own star chart, just like mine. That's what's going on overhead. We've got the two largest planets there, Jupiter and Saturn. So that's a thing. We're approaching new moon, my favorite phase. And let's do a solar system forecast. There's where things are today. Let's advance that 1 week. Crescent waxing will be the moon phase in 1 week, and that is where heavenly bodies will be located. Next, check this out, folks. This is a pretty sweet one. The astronomy photo of the day. I guess I better full screen this one because it's pretty epic. So, yeah, this is nice. So, from the farm country of France, we've got some Sarah, known as stable arc Aurora, stable Aurora red. ARC. That's what it stands for. Stable Aurora Red. Stable Aurora Red. Stable Aurora Red ARC. So a fantastic view. We showed a video yesterday of one over Arkansas. Kind of similar there. Also a great view of the Milky Way galaxy above that. And that is one massively high resolution image. Here's this spectacular view of the Milky Way. Very nice. Not half bad. So those red aurora actually happen at a higher altitude than the more familiar colors, somehow making it into the inner magnetosphere. And we've been seeing increasing stories of stable aurora red arcs. The question is, are they really more common, or are people just more likely to have a camera to take a photo or video of them? I'm not so sure. They have been documented, certainly, for decades. Yeah, for decades. So, I don't know. I don't find myself spooked by red aurora. A lot of people are, so. Anyway, let us know in the comments what you think. It's time to move on to CMEs. Check it out. Yowzers. CMEs are what we'll bring to you tonight's likely auroral shows. So make sure you tune into the Twitter channel tomorrow. There should be some great shares over there. If you want to share imagery you've taken of the aurora, hit us up. So anyway, these are yesterday's CMEs. There were some. Make sure you watch yesterday's daily space weather video if you want analysis of those. That is 93 frames from November 10th. Here come an additional 82 frames from today, 11/11. We do have one CME popping off there in the northwest. Besides that, things have been pretty chill. Let's take a look at C3 as well. There's C2 and C3 together. Looks to me like no additional earthly directed events. Let's just advance this manually. That didn't load right. I don't know. Something's going on with that. But our custom images worked fine. Let's see if Stereo A loaded. I think their website might be overloaded tonight. Yeah, it looks like it's returning nada. Well, the difference imagery is still pretty good. But let's just move to our custom coronagraphs. There is missing data on the ISWA site, the Integrated Space Weather Analysis Center. That is NASA's site. And that's Mercury that you see there moving across the C3 on the left. Mercury just turning the corner here as it catches up to Earth. That's a 24-hour video. Soho Lasco C3 in blue, C2 in red, and the SDO 193 angstroms. Here's a little closer view. Again, that CME came from this active region right up here. Nothing too exciting. Here we've dropped the C3 and we've added 304 angstroms as we transition to filaments. And you can certainly see a lot of large and dense plasma filaments. So very high likelihood of coronal mass ejections, folks. Remember, folks, you don't need to see solar flares or even sunspots to see coronal mass ejections. They happen regularly, even at solar minimum. So, of course, there are more of them around solar maximum. So, but yeah, lots of major plasma filaments. So let's take a look at some more. Here's Big Bear's hydrogen alpha imagery. And let's bring up the last image here and do a quick count. So this is 1. We'll call that 1. This is 2. Here's 3. Now this is a separate one here. I'm going to say that's 4. This is 5, 6, 7, 8, 9, 10. At least 11 filaments. You could argue that there are 12, that this one's maybe 12. maybe 13, maybe 15, 16. Lots of filaments, folks. Lots of filaments. So that's Big Bear's hydrogen alpha imagery. Here's the grayscale that also shows the overlap, so you can see prominences. A great way to view prominences. And we showed some in our first clips. There you go. There are some more views of prominences. So, ta-da, I'm back. So that's what's going on. And again, make sure you follow us over on Twitter. If you don't follow us over on Twitter, you might not see memes like that. Also, if you want to name filaments after living people, do it over there on Twitter. That is the place. That is the place to do it. Hashtag name that filament. And before we get to bonus features, here are the past few hours. Ionized helium as detected by the GO-16 SUVI. And here come bonus features. So bonus features starting out with satellite charging hazards. We've got some interesting internal charging hazards there. So high energy electrons there getting inside of spacecraft in the Central Pacific Ocean. There you go. Some internal charging hazards for you. Not every day you see that. So that could cause some errors in the satellites themselves as opposed to the communications errors you'd expect from surface charging. Goes electron flux there, kind of in electron storm levels. Not as high as it gets, but pretty high there. It's just after noontime for the GOES-18, which is what this red N represents. Remember, folks, that is in a geosynchronous near equatorial orbit, the GOES-18. Just entering its afternoon. So there is the 1 year graph of it, and highest levels here. Really, we're about where the highest levels we've seen since, what is it? Back in June, since we've seen an electron storm of this magnitude. And it could even get higher here, but we are expecting to see a huge dip in this as it becomes erroneous during a geomagnetic storm. So there you can see the forecast for, indeed, increased levels of electron flux. And I suspect it's going to drop way down and, again, become erroneous as a result of the geomagnetic storm. If you want to read about that, like why it becomes erroneous, it's basically because the ionosphere puffs up. You can read about this on the GOES electron flux page. These tabs down here, impacts, details, history, data, etc. Anyway, that's NOAA's forecast model, and I'm not expecting that next yellow diamond to be anywhere near there. In fact, it should be way down here. So we'll see on tomorrow night's daily space weather video where it really is. And let's get to the ever popular ionosphere. And we're going to show you one slice. Feel free to pause the video in this frame if you're not familiar with atmospheric temperatures, the penetration of electromagnetic radiation, and chemical concentrations. Here's the vibrational frequency of the F-layer, the bridge between Earth and space. It's one slice at about 300 kilometers of altitude, and expect to see a lot lower frequencies on tomorrow's daily space weather video. For now, it's still geomagnetically calm conditions, as that CME has not struck Earth yet, but it's getting awfully close. It's almost here, folks. If that's all Greek to you, don't worry. Here's the anomalygram. That's anomaly in megahertz from a 30-day median. It does a great job of showing the South Atlantic anomaly, which is right over the South American continent, right about here. And again, you could expect to see even more low-frequency anomalies on tomorrow's daily space weather video. At the moment, things are geomagnetically calm, so no major perturbations in the ionosphere. There's the latest image, 23:15 Universal Time. And let's go on to the WHAM. WHAM! The whole atmosphere model. Total electron content and anomaly on the left, maximum usable frequency and anomaly on the right. A quick snapshot of the global ionosphere and beyond, actually. And as we zoom in closer to our meteorology segment, we'll also show the total electron content by itself. That's free electrons to about this type of a distance, a run of about 12,500 miles. By the way, I do not like, it looks like it's erroneous. Anyway, here's the anomalygram. That's anomaly in electron content from the 10-day average. We are seeing some quite high electron anomalies here over large portions of North America. Let's rock it back. Some big-time electron content anomalies there over large parts of the U.S., Mexico, and the East Pacific especially. So that is our penultimate section, the total electron content. Here's the final section of space weather, the latest high-res images. Looks like we can fit all three of these sunspot groups. There we go. Very nice. We'll also get this group. And by the way, folks, remember, a flare watch continues. So we could see SEPs. There's lots of stuff that could be going on in space weather in the coming days. Also looks like we may have some sunspots forming here. So I'm seeing a little bit of magnetic organization happening right in here. Is there a sunspot? Not so much. Anyway, let's move on to meteorology. So first thing we're looking at here when it comes to meteorology is we are looking at, hey now, that is total cloud water. So this gives you an idea of how much moisture is in the clouds. And that's a pretty high moisture area there. That's 1.9 kilograms per meter squared. Keep in mind it is essentially a two-dimensional representation of total cloud water in that area. And let's show the whole globe view while we're at it. It gives you an idea of how moist the moisture indeed is. So that's a little atmospheric river, the one that's showing up here in Siberia. That is a major atmospheric river. Check that one out. That's a way more significant Pacific moisture mass. And huge variations of how much moisture is in that massive system. And of course down here, this is surface winds. You've got a huge anticyclone down here with this characteristic northern hemisphere clockwise rotation. Again, that's total cloud water. An important feature to use if you're trying to forecast the amount of precipitation that'll happen from a system. That along with a lot of other data. So I just figured I would show that. I don't think we've ever shown that on the channel before. Let's get to our regularly scheduled air masses. So, yes, this is the meteorology segment. Shout out to our viewers from the east side. There are your surface winds. Here are your jet streams. Jet streams from the central world. Surface winds for Europe, Africa, and the Middle East. Surface winds of the west. And these are the jet streams of the Americas. Next, clouds and fog over the west. A lot of cloud nucleation happening there in Brazil on this fine spring evening. And here's a little close-up of the Pacific Northwest, where that little, it's really more of an atmospheric creek. It's not really an atmospheric river. It's a bunch of moisture from the Pacific. But I don't think it's not big enough to be a river, folks. It's an atmospheric creek. But there is some snow falling in parts of Washington. So here is our precipitation type map. And we've got some wet snow falling around the Great Lakes region. The more significant moisture is showing up around Montana, Idaho, Oregon, and Washington. So some snow, wet snow, even some freezing rain mixed in there in some isolated locations. That's precipitation type from windy.com, a great map for you if you've never checked it out. Windy.com. Here's weather.gov. Alaska's full of warnings. If your location is lit, just head to weather.gov. Because you so lit. That is lit. Or something. And next, some forecasts brought to you by Tropical Tidbits. TropicalTidbits.com is where we typically get our forecasts from. There's a 72-hour GFS, pressure and precipitation. Like we said yesterday, a major system about to form around Texas and then kind of move right around the Gulf Coast. Also, a second wave of moisture coming to the Pacific Northwest. The Pacific North moist. Next, surface winds and pressure. Yeah, mean sea level pressure and 10-meter wind speed. So some heavy winds coming to Montana, also the Pacific Northwest, and the Great Lakes going to have some windy conditions. Also the Gulf will have some very windy conditions. Winds getting up to like 70 miles an hour there around the Louisiana coast. Well, anyway, there's the map, 72-hour GFS model. Last but not least, jet streams to show you the main controller of weather. I mean, it moves systems from west to east for the most part. Although it does allow warmth to come up north, it also allows cold to come down south. The 250 millibar winds on the GFS 72-hour model. Next, lightning. But first, TropicalTidbits.com. Another little plug there for you. TropicalTidbits.com. Check it out if you want to make your own lovely weather forecasts. And next we've got lightning. So a bunch of lightning there around Central America and northern South America for the past about 10 hours. Very nice. Also the Caribbean seeing some lightning. And here's a real-time lightning map courtesy of lightningmaps.org. We've got some strikes over here around the eastern Mediterranean. Some isolated but rather severe thunderstorms going on over there. Also in the central Atlantic and Central America. We'll close this mother out with U.S. Doppler radar. Some heavy storms up there at Alaska. We're going to focus on the lower 48. Clouds and fog. And there is the water vapor. When your Doppler's unclear, use the water vapor map. Did you know that this air is more massive than this air? Those are highs and lows, relatively speaking. This dry mass of air acts like a barrier, constraining this moisture to its south. Yes. Facts about meteorology. You could forecast your own weather. You've got plenty of data. We empower our viewers to do just that, forecasting the weather all the way from the closest star and beyond. Down to ground level, there's Doppler. There is clouds and fog. 3.9 micrometer infrared radiation. It also shows you if it'll be clear to see the Aurora, and it's clouding up over Pennsylvania, so we probably won't get any. That's a shame. And there is the water vapor map. Again, if you do have auroral imagery to share, make sure you share it with us. On Twitter is the best place to do it, as we've got massive sharing over there. So hit us up. If you, I don't know, hit us up on social media. Share your auroral imagery with us. Remember, folks, if you see the aurora, make sure you take camera footage of it, because, dude, most of it's ultraviolet light. Most of it's not even visible to the naked eye. So take photos, take videos. Learn how to set up your camera correctly to be able to video the aurora. Maybe become a member of the Smash team at smashomash.com/Smash team. And in the meantime, may that solar wind be at your back.